Hello guys, welcome to JER Hub Mathematics and Statistics lessons. In today's video, I'm going to be talking about a system of simultaneous linear equations. System of simultaneous linear equations. But before I begin, smash a like on this video if you like our content. Thank you very much for your views to our videos. Thank you for your subscriptions. For those who have subscribed, thank you for watching our videos. Thank you for sharing our videos. We are very grateful from the management decks of GER Hub. Okay, if you haven't subscribed but you've been watching our video, thank you for watching the videos. But please smash a like on our videos and make sure you subscribe. That being said, let us now go back to our focus for today's class: system of simultaneous linear equations. Now in this video, I'm going to start with answering the question that borders around the key words system. I'm going to explain the word system, I'm going to explain the word simultaneous, and I'm going to explain the combined words linear equations. Okay, so I'm going to explain system, I'm going to explain simultaneous linear equations, and I'm going to explain that in the sense that I'm going to discuss simultaneous and I'm going to discuss linear equations. So let us begin. Now let us start with the word system. On one hand, I'm going to put here system. Here, I'm going to put simultaneous. I'm going to put the word simultaneous. And I'm going to put lastly the combined words linear equations. Okay? Linear equations. So in the first, I have system to explain what it means. In the second, I have simultaneous. And in the third, I have linear equations. Okay? Now, I'm going to start with these words, linear and equations put together, that is linear equations. So the question is, what is a linear equation? But let me start with telling you why it is very important that in this video I explain this topic, system of linear equation. It is because it will set a pace for the student to understand what they have been solving. Some students have been solving systems of linear equations even without understanding what the concept actually means. Now, let me start with the words put together, linear equation. What we call a linear equation is this. So a linear equation must first of all be an equation, of course. So a linear equation is an equation of the form. It's an equation of the form. I'm going to write it below here. ANXN, okay? ANX rather. So this is 1 here, okay? ANXN, AN minus 1, XN minus 1, plus AN minus 2, XN minus 2, plus it goes on up to A2 x2 plus A1 x1, and if possible A0 x0 equals B. So equals a constant B. Let's put it that way. Now notice what is going on here, that you can generally write what is called a linear equation in this form. This will be a linear equation, take note, in n variables. So there is a variable xn, there is a variable xn minus 1, there is a variable xn minus 2, there is a variable x2 eventually that we will get to, and there is a variable x1, and if possible another variable x0. So what it means is this: a linear equation is an equation of this form having an an minus 1, an minus 2, a2, up to a2, a1, and a0 as coefficients. They are coefficients because they stand beside the variable, or they are used to multiply each of these variables. Now, what it means is that it is particularly linear. It is an equation, of course, because you will notice that we are comparing with equal to some group of items or terms on the left hand side with some group or a particular item or term on the right hand side. So it is actually an equation, okay? Now, there is that comparison with equal to, so it's an equation. Now, it is linear, this equation is linear because of one particular thing. If you notice something about the variables, there are n variables starting from x0 to n in this equation. Notice one thing about the variables: the highest power of each of these variables is 1. So the power of x raised to power x, the power of xn is 1, the power of xn minus 1 is 1, the power of xn minus 2 is 1, the power of x2 is 1, the power of x1 is 1, and the power of x0 is also 1. So what it means is that in a linear equation, which must be an equation, the power of the variables involved must all be 1. Another thing you should notice is that from this expression or equation I have put here, it shows you that in linear equations you can have more than one variable. You can have more than one variable. Now, that is another thing you must note. So if we go by that, we can actually redefine a linear equation to be this. A linear equation is an equation having variables whose highest powers are all ones, okay, and having no interaction between the variables, okay. Now I'm going to explain that. So if you go by what we have just put here, you would notice that what is called a linear equation must be an equation to start with. 2, what is called a linear equation can be in a number of variables. It must not be in one variable. It can be in a number of variables. In this case, n variables. Now, it must be an equation in the sense that it must compare a left-hand side comprising terms to a right-hand side comprising one term or more. So it must be an equation. So it must be linear in the sense that the highest power of the variables involved, all the variables involved must have their highest power as 1. And take note, there must be no interaction between the variables. Means xn cannot multiply xn minus 1, xn minus 1 cannot multiply x1, x2 cannot multiply x1. No two variables can multiply themselves, number 1, and no single variable can multiply itself. So you cannot have x squared, of course, because the highest power must be 1. So that is what a linear equation is. If you don't want to put it in this form, then you can put it verbally as a linear equation is an equation having variables whose highest powers are all ones and having no interaction between the variables. Good. That being said, let us see examples of linear equations. So this can make a linear equation. 2x plus 5 equals 6. This can make a linear equation. Why? In this case, there is just one variable, x1, and it is clearly linear because the power of this variable is 1. It is an equation because there is a term here, 2x plus 5, compared with the equal to 6, okay? So this is a linear equation in one variable. Now, you can have a linear equation in two variables. That is 2x plus 5y can actually be equal to 6. This will be a linear equation in two variables. So, why is it a linear equation? It is because there is the highest power for x here, 1, and there is the highest power for y here, 1. So whether it is one variable, two variables, or three variables, or more, the highest power of each of those variables must be 1. Now, if it were to be a linear equation in three variables, where you have 2x plus 5y plus 6z equals 6, notice that X has the highest power 1, Y has the highest power 1, and Z has the highest power 1. So these three examples are examples of linear equations. So it means that you can actually have more than 3 linear equations. So if we wanted to write for more than 3, you can now convert it to x2x1 that one is a linear term. 5x2 with x2 carrying the highest power of 1 is a linear term. 6x3, you see, is a linear term. And you can have 4x4 with x4 carrying the highest power of 1 is a linear term, all equal to 6. Now, notice that it may come to a point where you don't have to use x, y, and z again, but you now have to start, because you have so many, you may start using x1, x2, x3, x4, or y1, y2, y3, y4. But in any case, provided you know that linear equations can have more than one variable, what is important is that the highest power of the variable must be 1 for it to be linear. 2, another thing that makes it linear is that there must be no interaction between any two variables. So there must be no interaction between x and itself. So you cannot have this. Even when there is just one variable x, you will notice that this term here carries a product of x and itself. So this is not a linear equation. It is quadratic because the highest power is 2. If you have 2xy plus 5y equals 6, this is not a linear equation because there is an interaction between x and y. There must be no interaction between the two variables or the variables in what is called a linear equation. There must be no interaction, and there must be no interaction between a variable and itself or a variable and another variable. So this is not a linear equation. This is also not a linear equation if you have 2x squared plus xy plus xz. This is not a linear equation. All this equals okay, let me put this as this. Okay, so this is not a linear equation because there are interactions and there are powers of 2 in the expression. So these are not linear equations, but these ones are, because the highest power of the variable is 1 and there is no interaction between the variables. So a linear equation is an equation having variables whose highest powers are all ones, and having no interaction between the variables. Now, the next thing I want to tell you, remember our focus is to discuss system of linear equation, and I want you passionately to understand what we mean by a system of linear equation, because subsequent videos will be talking about methods for solving system of linear equations. I'm going to be taking the methods one after the other. Okay, so in this video I want to furnish you with details on what a system of simultaneous linear equation is. Now let us go to the next thing I want to say. Now, how many solutions an equation has depends on how many variables you have. Okay, in this case, this particular equation would have one solution because there is one variable. Okay, and the variable more so is linear. So when you solve a linear equation in one variable, you should be expecting one solution. In this case, if you were to solve this, 2x will be equal to 6 minus 5, and x will be equal to 1 over 2 because 6 minus 5 is 1, and when you divide both sides by 2, you end up having half as your result. So one linear equation in one variable carrying the highest power of 1 gives one solution. Now, take note, if I had one linear equation, if I had just one linear equation, 2x plus 5y equals 6, you cannot solve, or you should not solve, one linear equation involving two variables using just one linear equation. Why? The only solution, the only kind of solution you can give to this problem, that is one linear equation involving two variables you want to solve for. If you are to solve this problem, at best you can give it what we call a trivial solution. At best you can give it what we call a trivial solution. So what is a trivial solution? A trivial solution comes with you assuming x, one of the variables, to be 0 while you obtain the other one. So if I wanted to get a trivial solution to this problem, what I would do will be to assume what x is in this case 0, and find y. So if x is 0 and you put 0 in place of this will become 2 times 0 plus 5y equals 6. And in this case, y will be equal to 6 over 5. Okay? Because 2 times 0 is 0, and that 0 adds to 5y to give 5y. And when you divide both sides by 5, it gives you 6 over 5. Now, if you were to obtain, still on that trivial solution, if you were to obtain a trivial solution also, you have to assume that y is 0, and when y is 0, you have to obtain x. So the value of x will be 2x plus 5 times 0 equals 6, meaning that x will be equal to 6 over 2, which is 3, because 5 times 0 is 0, and 0 will add to 2x to give you 2x, and 2x when divided both, when 2x is equal to 6, dividing both sides by 2 will give you 6 over 2, which is equal to 3. Now, this will be a trivial solution to that problem. 2x plus 5y equals 6. But not all the time do we require you to give trivial solutions to a particular linear equation. So what is proper is not to always obtain trivial solutions, because they don't really explain the true nature of a linear equation. So what do we do? That brings me to the word system. Okay? So in order for you to solve one linear equation involving two or more variables, you would need a collection of linear equations. So what is called a system is a collection. A system is a collection of, in this case, linear equations. So what we refer to as a system in this topic, system of simultaneous linear equation. A system is a collection of linear equations. What kind of linear equations? A system is a collection of linear equations to be solved at once for the variables involved. To be solved at once for the variables involved. Okay? Now, mark that word at once. At once brings us to this. When you solve, if you are to solve, like I said earlier on, you cannot solve for two variables using one linear equation. For you to solve for two variables using one linear equation, you would have to do what is proper. And what is proper is to look for another linear equation in two variables, which can be used to form what we call a system, a collection of linear equations that can be solved at once. And solving at once means solving simultaneously. So simultaneous here, simultaneous implies that the collection of linear equations must be solved at once. Okay? So collection means a group, or the system means a collection of linear equations to be solved at once. And at once means simultaneous. Now, why are we using a group of linear equations? It is because we know that aside one linear equation in one variable that can be solved easily, when you have a linear equation involving more than one variable, you would need more than one equation, linear equation, to solve that problem. So if you want to solve this and you don't want a trivial solution, you must look for another linear equation. So if I wanted to solve 2x plus 5y equals 6, what is proper if I'm not looking for a trivial solution is to look for another linear equation in two variables, say x minus 4y equals 5. I will look for another linear equation that will be solved at once with 2x plus 5y equals 6. And together, they will form what is called a system. And this system is a system of what? Is a system of linear equations that should be solved at once. And because they are to be solved at once, it becomes simultaneous. Okay? So simultaneous means they must be solved at once. And when you solve a collection of linear equations, that is a system, at once, that is simultaneous, then it means you are now solving a system of simultaneous linear equations. So, put together, that being said, let us now define here what a system of simultaneous linear equation is. So, a system of simultaneous linear equations is a collection of linear equations to be solved at once for all the variables involved in the system. Okay, and that defines what a system of simultaneous linear equation is. Now, to end my discussion in this video, remember, in subsequent videos we shall be looking at methods for solving this system of simultaneous linear equations one after the other. Now, to end my video, the question I want to answer is, what methods are available? Methods for solving a system of simultaneous linear equations. So what methods are available for solving a system of simultaneous linear equations? What methods are available? Now, I'm going to mention some methods that are available. Number one, but they won't be discussed in this video. In my subsequent videos, I'm going to be taking them one after the other. So you watch out for videos that I'm going to be uploading on this. Number one method is the elimination of variable method. The elimination of variables method is one method for solving a system of simultaneous linear equation. Number two, the method of row reduction. The row reduction method, otherwise called Gaussian elimination method. Okay, so this method, the row reduction method, otherwise called Gaussian elimination method, is another method for solving a system of simultaneous linear equation. 3. The next method is the Cramer's rule. This is another method for solving a system of simultaneous linear equation. The fourth method is the matrix method, what we call the matrix method. Okay? And the final method is the method we call the LU decomposition of a system of linear equations. So the LU decomposition method is another method. Now, in my subsequent videos, I'm going to be taking each of them in my videos one after the other. So I'm going to make a video on elimination of variables method, the row reduction method, the Cramer's rule, the matrix method, and the LU decomposition of a system of linear equations method. So you watch out for those videos. Thank you for watching this video. Thank you, and thank you. Make sure you hit the subscribe button and make sure you smash the like button. I'll see you in my next video on any of these methods. Thank you very much, and thank you very much.